Hey, hi everyone. My name is Nicholas, and I work as a consultant at Limbic. So I will be discussing a library for runtime checking over Elixir. So the title is a bit misleading that it's about a specific library called type check. So I have a feeling that most of you here are at the very least familiar with types. You are after all at an Elixir meetup, and this is something of a hot topic in the Elixir world at the moment, with talk of set theoretic types coming potentially. I'm sure many of you are experts, but I'm not actually going to make that assumption that you are experts, because there might be someone in the audience who's new to Elixir, someone who's new to types, or someone who's new to programming altogether. My motivation for considering this possibility is actually a messenger group chat with some friends where I was informing them that I was doing a talk at a meetup. Upon being asked what my talk was about, I wrote a succinct and accessible summary on the topic. Their responses were, "That went over my head," and "No idea, but sounds good." So the first part of the talk, I will be giving a pretty gentle introduction to the concept of types with really minimal syntax. I don't know if this would offer any clarity to my friends, but they have no familiarity with programming at all. But hopefully, if you have even a modest familiarity with programming, this will be helpful. On the other hand, if this is too basic for you, and I have a feeling for most of you it will be, you continue thinking about image processing, or perhaps you can find an answer to a question earlier in the evening. But the other aspect of this benefit of this is it will motivate the rest of the talk, because after this gentle introduction, we will move on to talking about how issues can arise in Elixir, and then specifically how this library type check can partially solve these issues. Okay, so again, this is a very gentle introduction to types. Basically, a type is a property that is assigned to a unit of data for the purposes of defining what operations or manipulation involving said unit of data can be performed. So as a concrete case here, we've got this basic function that takes two integers and returns the sum of them. So it returns an integer. However, we can't always guarantee, of course, that we will always receive integers into our function. So in this case, with one of them as a string, as in this case, this could cause a problem. So again, in case there is anyone in the audience who's completely new to coding, these two characters are very different. The one on the left is an integer. It's something that can be used by our code to perform arithmetic operations. The one on the right, in quotes, is a string. It is not something that is used in arithmetic operations. It's more used in like sentences, descriptions, or instructions. Okay, and so trying to perform an arithmetic operation on that could cause issues. And similarly, another issue that can occur is if we have a function that wants to say get the length of a list. This first instance, things are fine. It returns 3 because there are 3 items in the list. But then what happens if we try to do this? What does that mean? We could try to write our function to adopt to this. Like perhaps we could say just returns the integer 5. But we shouldn't have to do that. We don't want to do that because it makes things a bit squirrely. Okay, so brief summary, things like 1, 2, 3, integers, things like numeral 1, the letter 1, the word house, this sentence, all have type string. And then we also have things like Boolean. Booleans consist of values true and false. They're used for logical operations. Similar to integers, the string true is not the same as the Boolean value true. Then we have list types. So you have like a list of integer is a type in itself. And you can see examples there. And then you have list of string. Then you can create unions. So this is an example of those are all examples of integer union string. I've got a Venn diagram here to kind of visually show how this union type is what you get if you treat all the members of each type as their own respective set and then apply the set theoretic operation of union. I'm sure all of you are familiar with Venn diagrams. And then functions themselves have types. For example, a function that takes two integers and returns true if the first integer is less than the second and otherwise returns false, has this expression. So the part on the left denotes the types of the variables being passed in, and the part on the right denotes the type of the value being returned. So one takeaway of this is that types can be built from other types. To me, it's kind of reminiscent of how sentences in English and possibly all natural languages can be built from other sentences. Like the sentence "we eat donuts" can be used to construct other sentences like we eat donuts only on Friday, or it is slander to say that we eat donuts. So list types, union types, function types are all examples of types that are built from more fundamental types. Just making this point because later on when we do get to talking about the type check library, if you're not familiar with this concept, maybe this is confusing. So issues and bugs arise at the lowest level because at the fundamental level, you're just kind of manipulating bits, so to speak, units, ones and zeros, and concepts such as integers and strings do not exist at this most fundamental level. So it's something that emerges at a higher level of abstraction. So there aren't necessarily any inherent constraints that are going to stop you from writing nonsensical things that could cause bugs. But these high-level extractions can be leveraged to avoid these problems. For one, explicitly defining our types can kind of act like proofs. They add some level of guarantee to the behavior of our code. In essence, a type of a function reassures us that the function will behave without any big surprises. The question then is whether this is enforced at compilation. And if it's not enforced at compilation, just how useful is it? And so that's partly what we'll be tackling later on. Also, just from my own experience, and another secondary perk that arises from having a type system is when you're trying to navigate around a code base for the first time, it's unfamiliar to you, having types can act as a type of documentation. So if there's the appropriate specification of the type for a function and the function is well named, we can get an idea pretty quickly of what its purpose is without having to pour through the logic. So there is static typing, and this is where the at compile time, the validity of the types will be verified, as I just mentioned. And a function and anything that's proven not to be valid will cause an error during the compilation. So this is something that Elixir does not do. However, there is currently an effort with a research project by Jose Valim, Giuseppe Castagna, and Guillaume Dubois. I don't know quite how to pronounce that last name, so apologies, as part of his PhD studies. If you're interested in this at all, and this is new to you, there is a recording of Jose Valim on YouTube speaking at the Elixir conference last year. The talk is called "The Foundations of the Elixir Type System." In the meantime, though, we have to try and catch these errors during runtime. So Elixir does have type specifications. They just have no effect on compilation. So for a function, we can specify the input types and the result type like so. Here we have a practically pointless summation function, but it demonstrates what I'm talking about. It tells us that if we take in two integers and it returns an integer. Here we have a slightly more realistic example that isn't quite as redundant as that summation function. So Elixir has structs, which are a data type which contains specified specific fields which can be accessed. So here we define a struct for cat, and a cat struct can only have the field's name and fish per meal. And so there we have an example of our cat struct with name Jill and the number of fish it eats per meal as being 10. So going back to where we define the cat struct, we see the type specs where basically it tells us that the name field must take that it is a struct, and that it takes in a field for name that is a string, and then it takes a field in for fish per meal, which is an integer. So now I've got here a cat helper module. And we've got this function called isFull, and basically, so the type specs actually tell us that it takes in a cat struct as we just defined it in the previous slide, and an integer, and it returns a Boolean. So this is a very simple example of what I was saying before of how types act as documentation. Just by the name and the type specs alone, we can guess what this function does. If we look at the actual logic, we can confirm that for a given cat and the number of fish in its bowl, this function returns a Boolean which states whether it has eaten enough. We have another cat help function, how many more fish, which takes in a cat struct and an integer and returns an integer. This function tells us how many more fish the cat needs to eat to be full, but otherwise returns 0. Okay, so this is nice documentation, but again, like I said, it has no actual effect on the compilation. So what happens if I try something like this? Here we have a cat struct which breaks the type specification because it has a fish per meal field that is a string. However, morally speaking, we could argue we should get false because the cat is given 4 fish, and the fish per meal for this cat is the string which typically denotes the integer 10. And there are all sorts of scenarios where this could happen in the real world. So what happens? We get false, which is perfect, right? That's what we wanted. Problem is we can also run this, and using the same argument that we just used, and maybe we should get true. But guess what? We get false again. And this comes down to, in Elixir, both of these return false. Because basically the less than or equal operator doesn't see the string 10 as an integer, as something it performs arithmetical operations on. So this is a risk with not checking our types. Our code hasn't actually blown up yet, but we have now introduced nonsense into our system, which is potentially arguably much worse than things blowing up. But chances are sooner or later things will blow up. So we could imagine a scenario where our code progresses past the point of determining the function is full, and we might need to calculate how many more fish. This time we get an error. Elixir balks at trying to perform an arithmetic operation on the string 10. Now this is a fairly contrived and oversimplistic example I'm giving here, but in the real world, there are going to be situations where these pieces of logic, or their real world analogs rather, are far downstream of one another. And so if things blow up, we could potentially have a real headache trying to figure out what's going on. We really would prefer to stop invalid data at the earliest point possible, ideally not even let it get past the point of entry. So we can mediate this problem by adding guards and or writing helper functions that will do these checks for us. Problem is, this is a lot of work, which is prone to gaps. Furthermore, writing it is so the error messages are easy to understand and idiomatic with respect to Elixir's types and type spec in a systematic way is pretty non-trivial. So without without static types, we're not going to be able to stop faulty types at compile time, but maybe there is a compromise. Maybe there is a runtime solution which more or less addresses those issues I just stated, I just listed. Is there something that leverages Elixir's existing type spec syntax in a way that it can handle and display errors idiomatically? A way to stop invalid types at the beginning rather than letting them propagate down the pipeline and causing us nonsense or things to blow up. Yes, and there is, and that's the subject of this, the subject of this talk, and it's type check. So type check is a library that does just this. It can be easily added to the project. You simply add use type check at the top of each module. We then write near exact syntax as what we had for the type specs, except now there is an exclamation point at the end. And so at compile time, the type check code creates a wrapper around our functions. So going back to the examples I had before, I've now added type check, and it looks basically identical. So what happens now when we try passing in our invalid cat struct from before? We get this error. The error tells us specifically that the first parameter does not adhere to the spec for our cat struct. Then it shows us what we passed in. It then gives us further details, at the bottom of which we finally read reason under key fish per meal, the string 10 is not an integer. So we see that it seems to work well when we are defining our instructs, so this is good. But we can also add specs for other things we mentioned before, like list of strings. Here we have a function called getFirstName, which takes in a list of strings, and I guess by the name of the function, the assumption is all the strings are names, but that doesn't really matter. And it returns the first string at the beginning of our list, unless the list is empty, in which case it returns an empty string. And we have the specification which says this function takes in a list of strings and returns a string, except now there is an exclamation point after the spec at spec icon at the top. So if we try to pass in a string, in this case Bob, rather than a list of strings, we get this error. And indeed, we see that we get the reason Bob is not a list. On the other hand, if we try to pass in a list of integers, this time the reason is that 4 is not binary. And for clarification, I'm sure everyone knows this, but that's consistent with it not being the string type. So this checks out too. It did occur to me that given that the function I just wrote only really cares about the first entry of the list, maybe I could full type check if I passed in a list with the first entry as a string, or with some other entry as an integer. But as you can see, it wasn't fooled. And so let's check type unions. Here we have a function that takes a string or integer and returns a Boolean. You can probably tell at this point I started giving up trying to come up with sensible examples, but even if the function is a bit silly, still illustrates the point, which is if we try to pass in something that isn't a string or an integer, like a Boolean, we get this error. And the cool thing about this error is it actually lists the two different possibilities of failure. Right? So the 0th one tells us that true is not binary, and the first one tells us that true is not an integer. Now, finally, I thought it'd be worth checking anonymous function. I did describe function types in my intro after all. In particular, I wanted to test how well it would handle unions in function types. Can it handle more specific function types? So we have this function in our module that returns an anonymous function when we call it for whatever reason. And the anonymous function it returns negates the value of either an integer or a string. So example, if you pass in 1, it returns -1. If it's true, it returns false. So in this first case, we have written the type of this returned anonymous function to take an input of union type, in this case, a union of integer and Boolean, and it returns the same type, a union of integer and Boolean. And this is quite an expansive type for this anonymous function, because this includes functions that take an integer and return an integer, take an integer, return a string, take a string and return a string, take a string and return an integer. Sorry, sorry, my Boolean. Replace what I just said with string with Boolean. So this works when we try this. But however, let's try a more restrictive type. We'll keep the same function that we had in this previous module, but now we'll write the type specs to say that the return anonymous function must either take in an integer and return a Boolean, or takes in a Boolean and returns an integer. So anonymous functions that fall within this type are a strict subset of those that fall within the type that I had in the previous, that I specified in the previous slide. In particular, the same anonymous function from the previous example does not fall under this type. So if we now try the same thing, we get an error. And indeed, it tells us the return result is not a Boolean. So we can see this works, that this this type check library actually works quite well. Actually, this library actually helped me in constructing these slides. So in trying to come up with examples to show my slides, in addition to creating a list helpers module, at one point I created a list of names helpers module. In addition to having very similar names, it also has similar functions. The main difference between being the get first name of list function in the other module, I would pass in a list of name structs, which in turn had a list of names field. So if you're getting a bit confused by these names, so did I, because when I was trying to copy an error to show in the slides, the type check error was saying Bob is not a map, but the list helpers module should have given me a Bob is not a list error. So maybe this library was making a mistake. But no, I completely forgotten that I had written this list of names helpers module and it was still floating around. So this error actually was useful. It actually helped remind me what I'd done, that I'd written this. And that's what actually happened. So that's the basically a summary of this library. I'll hand it back over to Mike.
All right, thanks very much, Nicholas. Yeah, so anyone online in the chat, post your questions. I think we've got time for a few. We're running pretty much on time. So yeah, there was some pretty impressive stuff in there, like checking, deeply into the structs and lists, and also I didn't expect checking the return type. That's pretty neat. That's something you can't do with just a guard on your Elixir functions. Is there any mention in the docs or in your time using it of the performance impact or like the cost of the additional checking?
I think there was. I can't remember exactly what I said. I think it was fairly minimal, but don't hold me to that.
Okay. Okay, one question from online. Does @spec bang work with tools like Dialyzer?
Yeah, I haven't actually tested myself, but I'm pretty sure that was something they specifically mentioned in the docs.
So it's some kind of macro that expands into a type spec plus a wrapper around your function.
I was gonna,
Like
yeah, I was gonna delve into like the behind the scenes code, but time got away from me. Behind the
that.
scenes, yeah,
That's fine.
into the code base.
Nice.
There is actually a talk about this on YouTube as well, if you want to maybe more in like technical in-depth talk about it as well. Where I assume the creator or one of the co-creators talks about it, and it's quite interesting too.
I'd never actually heard of it. Has anyone actually heard of it? Yeah.
It's come up on the forum a couple of times, but it always seemed a bit fringe.
I'm just curious that it gives you actual compile errors without using dialyzer.
Yes.
With pretty nice error messages.
Yeah, they're really neat. I was going to go further down the anonymous function path and like having what it looks like if you return. I have an anonymous function that returns another anonymous function, which is invalid. So I didn't actually check that out yet, but that would be a good thing to check too.
I think the only cost is every time you want to use it, you've got to use type check and put the bangs on.
Yeah, but I feel like that's pretty reasonable cost.
It's not terrible to have first class type check. Surprised Jose hasn't mentioned it. Maybe he didn't realize it.
Yeah, and I suppose you wouldn't need to use it for your entire application. Like if you're mostly concerned about.
Oh yeah, this is runtime. Sorry. Oh,
Right.
sorry. I thought yeah.
Okay, yeah. Takes away my question.
Yeah.
And I guess Rob just asks compile time errors or runtime errors.
Yeah, runtime errors.
Yeah. So I guess you would run Dialyzer in addition to this if you wanted to try and get some build time warnings.
Yeah.
Where it can. Yeah, very cool.
Cool. I'm going to stop sharing.
All right. Thanks again, Nicholas.